In this section, we are going to talk about geometrical meaning of the zeros of a polynomial. We'll first start with zero of linear polynomial, and then we'll talk about zero of quadratic polynomial. And then we'll talk about zero of cubic polynomial. And then we'll talk about conclusions. In this section, we are going to talk about geometrical meaning of zeros of a polynomial. We'll first talk about zero of linear polynomial, then we'll talk about zeros of quadratic polynomial, then we'll talk about zeros of cubic polynomial, and then we'll recap and draw our conclusion out of it. So let's talk about zero of linear polynomial. Let's take an example for linear polynomial as px equal to x plus 2. Now, in order to find zero of a polynomial in this case, we'll equate px equal to 0, which then will imply x plus 2 equal to 0, which gives x equal to minus 2. So the polynomial px equal to x plus 2 has a zero called minus 2. Now let's find this geometrically. Let's assume y equal to x plus 2. We know that the graph of y equal to ax plus b is a straight line. So every graph of y equal to ax plus b for different value of a and b will always be a straight line. Therefore, graph of y equal to x plus 2, where a is 1 and b is 2, will be a straight line. Now we need to find 2 points to draw a straight lines. So remember, if you have to draw a straight line, all you need is 2 points. So as soon as we find 2 points, we can connect them and draw the straight line. Now let's take, how can we do that? So we have x and we have y equal to x plus 2. Let's assume x equal to 1. What we get as y as 3, because if you replace 1 here, you'll get 1 plus 2, that gives you 3. If I take x as minus 1 and put x equal to minus 1 here, what we get as y is 1. So now I got 2 points, 1 and 3, and minus 1 and 1, and now I should be able to draw a straight line. So if you look into the point in the graph, this is a place where you can locate 1, 3, which is first value, and this is a place where you can locate minus 1 and 1, which is your second value. And now I can combine these 2 points and draw a straight line across. Once you do so, your straight line looks like this, and you can see this straight line is intersecting x-axis in the negative side at minus 2, and hence the coordinate of this point is nothing but minus 2 and 0, where y coordinate is 0. Now if you look at carefully, geometrically 0 of the polynomial is the point on x-axis where graph of the polynomial intersect. In this case, I got initially these 2 points and I draw the graph, and in this case the graph was a straight line, and we saw when we extended that straight line, it intersect x-axis at minus 2, and hence 0 of this equation y equal to x plus 2 is minus 2, because this is a place where y coordinate becomes 0, right? So in general, what can you do? In general, for a linear polynomial, what is linear polynomial? It is of the form of ax plus b, where a should not be 0, b can be any value. The graph of y equal to ax plus b is a straight line, which we have seen already. And if that is a straight line, it will intersect x-axis exactly at a point minus b by a and 0, because y coordinate is always going to be 0. So what you have to actually find is what is your x coordinate. Now let's take a look of zero of quadratic polynomial. So let's take an example of quadratic polynomial as px equal to x square minus 9. Now in order to find 0, we can equate px equal to 0, and hence x square minus 9 is equal to 0. If we break x square minus 9 as x plus 3 into x minus 3, because we know x square minus y square is x plus y multiplied to x minus y, hence we get x plus 3 multiplied to x minus 3 as 0, which then gives you x equal to minus 3 or 3. Now let's find this geometrically. Let's assume y equal to x square minus 9. Now let's try to plot the graph for y equal to x square minus 9. We can take different value of x and calculate different value of y using the quadratic polynomial, and hence if I take x equal to 1, we get y equal to minus 8. If I take x equal to 2, then we get y equal to minus 5, and so on. And now you got x and y coordinate. If you plot them into a graph, your points would look like something like this. For example, x equal to 1 and y equal to minus 8 is here. X equal to 2 and y equal to minus 5 is here. X equal to 0 and y equal to minus 9 is here. And x equal to minus 1, y equal to minus 8 is here. X equal to minus 2 and y equal to minus 5 is here. So I got almost 5 different points. Now if I try to really combine these points, it will give me a graph. And the graph in that case will look like a parabolic graph which is intersecting x-axis at 2 different points. Remember, plotting of graph for quadratic or cubic polynomial is not meant to be done by the students, nor this need to be evaluated. So you're not learning in this session that how will you really plot that graph. Another point to remember, any quadratic polynomial of the form ax square plus bx plus c, where a is not equal to 0, the graph of corresponding equation has one of the two shape. Either open upward like this is an open upward shape, or open downward like this. So if this graph get something like this, then that becomes downward. So remember, any quadratic polynomial can have either an upward parabolic shape or downward parabolic shape, and it actually depends on whether the value of a is positive or negative. So what it means, if the value of a is positive, greater than 0, in that particular case your parabola will looks like upward. And if it is negative, in that case your parabola will look like downward. Now if I go further, as I've been telling during the point of discussion, this is also known as parabolas. Now let's take an example of drawing graph of x square plus bx plus c. What can happen, right? Here the graph cuts x-axis at 2 distinct points a and a dash, right? So this is a situation when your a was negative value and this is downward parabola. However, if your a was positive, your parabola will be upward and it will intersect at 2 different points at x-axis. Will it always do? That's not true. This is one situation where you have upward or downward parabola which is really intersecting x-axis. Now you have another case where they will just touch x-axis. So here is the graph, right, that cuts x-axis exactly at one point as opposed to cutting it at 2 different points. And this is because all the 2 points coincide each other. And hence, in this case, when your a is negative, your downward parabola is basically touching x-axis at a. And so is your upward parabola, where a is positive, it is going to just touch x-axis at a. Now I have another case, which is third case, where the graph is either completely above x-axis or completely below x-axis. So it does not cut x-axis at any point. And in this particular case, your graph would look like this. For a is negative, and will look like upward like this for a as positive number, right? And in either case, for such graph, there won't be any solution. You won't be able to find any value of x where these graphs will intersect, and hence you will not be able to find any value of x. Now let's talk about cubic polynomial. And here is an example for cubic polynomial. I have x cubed minus 4x. If I equate this to 0, I'm going to get x cubed minus 4x as 0, which can further be broken down into x multiplied by x square minus 4, which is nothing but x square minus 2 square, and hence it can further be broken down into x multiplied to x minus 2 and x plus 2, which then gives you x equal to 0, minus 2 and 2. Now let's find this geometrically. What does it mean to you? Let's assume y equal to x cubed minus 4x. And now when you try to plot this on the graph, what you're going to get is different values for y while assuming value for x. So here I'm assuming x equal to minus 2, minus 1, 0, 1, 2, and I'm calculating different value of y. And when I try to plot them onto graph, my points is going to look like, these 5 points is going to look like for x equal to minus 2, y is 0. For x equal to 1 or minus 1, y is 3, which is this point. For x equal to 0, y becomes 0, which is this point. For x equal to 1 and y becomes minus 3, which is this point. And for x equal to 2, y becomes 0, which is this point. Now if I try to join all these points, again this is not in your scope to really draw these graphs, but if you join them, you will see here x-axis is being intersected at 3 different points for a cubic polynomial. And this is how your graph would look like, right? And now in this case, cubic polynomial has 3 0, same as the degree of the polynomial. And the 3 0 are minus 2 0, 0 0 and 2 0. Geometrical representation of 0 of cubic polynomial. Let's continue this. Let's take another example of cubic polynomial, and in this case y equal to x cubed. Now if you really try to plot them, you will see x has only value 0. And in that case, if you try to take different combination of x and y, you will see this graph is really going and intersecting only at one place, and that is at 0, and hence this cubic polynomial has only 1 0. If I take another example as y equal to x cubed minus x square, my graph is basically intersecting at 2 different points, at x equal to 0 and x equal to 1. And hence cubic polynomial has only 2 0 in this case. So now a cubic polynomial will always have 3 0 is not true. At the most it can have 3 0, but it can have 0 less than 3. So this is an example where I have 1 0. This is an example where I have 2 0. And previous slide we saw the example of 3 zeros. So what is conclusion? In general, given a polynomial px of degree n, the graph of y equal to px intersect x-axis at most n points. At the maximum it can intersect at n points. Therefore, a polynomial px of degree n has at most n zeros. What this means, if it's a cubic polynomial where the degree is 3, you can at the most have 3 zeros. You cannot have 4, 5, 6 zeros. But you can have 0 less than 3, which we have seen in the previous example. Thanks for watching. You can visit us on www.classisfun.com.